guys imagine a future where everything you need is only a click away? With the advances in 3D printing technology, this future is not that far off. So what is 3D printing and how does it work? 3D printing, better known as additive manufacturing, is the process of creating an object from a digital design file. The difference between traditional manufacturing and additive manufacturing, like the name suggests, additive manufacturing is where the product is built up from the ground to the finished product, compared to traditional manufacturing, where it is from a block of material and is honed down to the finalized product. The way 3D printing works is a designer goes in and creates a digital 3D rendering in design software such as AutoCAD, and then creates the file into an STL file format, which the printer can read. It is then given to the printer, and the object is printed out. There are two types of additive manufacturing: selective deposition and selective binding. Selective deposition works by extruding a material through the printer's print head and laid down layer by layer. Selective binding process works in a slightly different way, where the printer material is put on a print bed and slowly lowered, while a light source or a heat source is used to harden the object. The two main types of selective deposition printers are fused deposition modeling, or FDM printers, or laser engineered netscaping, or lens printers. Fused deposition modeling printers are the most common today, as they are the cheapest and work with the most simple materials. They are great for consumers to use because of the low entry cost. Laser engineered netscaping printers have a lot wider variety of materials that they can use. They can print in glass, plastic, or metal. Because of this wide variety of materials, it makes it more viable for larger companies such as the automotive industries and aerospace industries to use this type of printer. Selective binding printers are stereolithography printers and laser sintering. Stereolithography works by putting a light-sensitive liquid plastic onto a print bed, and a UV light is used to outline the object. As it hardens, the print bed is slowly lowered and more liquid plastic is poured on top and re-hardened. Laser sintering works in a very similar way, except instead of using a UV light and liquid, it uses a powdered material and a laser to do it. Additive manufacturing is rolling today. The main way that additive manufacturing is being used today is in the rapid prototyping process, replicating and replacing hard-to-find parts, generally in old machines and old cars, and making trinkets to sell on websites like Thingiverse. While the replicating parts and trinkets are a large part of manufacturing, the main use for it today is in the rapid prototyping process. The rapid prototyping process is where a company needs to create the prototype for the finalized product. This is generally done where a designer draws out a written rendering of the object and then later takes it and hand carves a model out of clay or foam. This is a very costly and time-consuming process, and where 3D printing benefits this is that the designer can create a digital file of it, print it out, and if it doesn't work, they can go back into the digital file and fix it and not start over from scratch. Developing technologies and future possibilities for 3D printing. The two main areas for developing technologies are in the end product manufacturing, where the finalized product is created straight off the bat, and in bioprinting. For end product manufacturing to make more sense, the price of the printers need to drop. At the current cost of them, it doesn't quite make sense, especially in economies of scale. Bioprinting, which is the most futuristic sounding area of 3D printing, is where a living tissue is mixed with a sugar cell matrix to print out a living organ. This organ is grown and then eventually transplanted into the patient. Bioprinting is still in the early stages of development and probably won't come out for the next 15 or 20 years. To sum it up, 3D printing, also known as additive manufacturing, is building products from the ground up. There's two main types: deposition, selective deposition, and selective binding. Selective deposition is pushing the material through a print head, and selective binding is used by lowering the material in a print bed. Uses for it today generally consist of rapid prototyping and making small trinkets to sell. But in the future, there's much more possibilities for advancement as the technology becomes more advanced and the price drops.
Okay.
Okay, so questions for Taylor?
Are there any regulations on finalized products?
As of current, it's just what the regulations are. So there's an quick example I'd like to tell. There's this guy out in Texas who's printing gun parts, and the only regulated piece on a gun is the receiver, or where the trigger assembly is put in, and he was printing that part, and the Firearms Regulatory Association told him that he couldn't do it, and actually made the company where he got the printer from take the printer back because he was renting the printer at the time. So on certain regulations like that, on certain pieces like that, the regulations are still out there, but he ended up going and getting his manufacturing license to produce firearms, and so he's doing it again. Yeah, so there are regulations, but it's since such a new technology, they're kind of regulations are being created as they go along, kind of like with the internet in 2000.
I have a question. So are these, are the objects that are printed up, are they always printed up through or created through like plastics? Or do they also use different kinds of materials? Because I'm wondering, like with something like a gun, you've got a number of different materials that are being used, and you've got mechanical parts and things that need to react to each other. And I'm wondering how that works. Like I understand a printing of like a baseball bat or something that's like uniform in terms of its materials and that doesn't have moving parts, but something that's got to be designed with lots of elements to it is a little bit difficult for me to understand. So.
Okay. Yeah. So as I said before, in the selective deposition printers, there's the ones that print in plastic, the fused deposition modeling, which is 80% of the printers out there right now are that style of printers because of it prints in plastic and is easier to use. With laser sintering or lens technology, the printers themselves, like entry costs are around $250,000. So a normal consumer would buy them, but for, as I said, automotive industries and aerospace industries, they're already using those to print titanium parts for airplanes or turbine blades because 3D printing allows them to create it in a way that's more efficient in terms of how they spread out the metal and stuff like that. So the technology is out there. It's expensive at the moment, so only larger industries are using them.
Right, but something like a blade for a wind turbine doesn't have moving parts necessarily in it. It's just a blade, right?
True. Okay, they can print moving parts as well.
Oh, okay.
Generally, how that's done is they're printed in multiple pieces at the same time, but in between the moving parts, there's like a plastic that can dissolve away. So it's got these plastics that hold everything solid together, and then you would dunk it in a tank that dissolves away the plastic, and then at the end of it is just a moving piece.
Other questions for Taylor? Okay, I don't have to call on people to ask questions, but I would like to have more than one person ask questions if possible.
How did you find out about this technology?
3D printing, I found out about it in like 2008 when I think that's when the guy started creating the gun pieces. Like it caught my eye. It was like kind of weird, like someone's printing guns. So I read up a little bit on that, and then in 2010, a couple more articles resurfaced that were very interesting. Printing finalized products, like they printed a dress out of some material, and then I think they printed Ford printed a transmission for a car in aluminum. So that got me really into it because I was really into cars, still am, and I was like, man, I could make custom one-off pieces with this or something like that in the future.
So is it more for like research purposes than anything else?
That why I'm into it, or
just
3D printing in general?
Yeah.
Yeah, I guess at the moment it's mostly being used for like just having a cheaper way to develop a prototype because it costs so much to do, and to send off the piece to another manufacturing company to create the prototype for you is too expensive. But when you can do it in-house on a plastic model, or in the case of a company like Ford, they can print a working prototype, that's pretty good. But it doesn't make sense for them yet to print, like Ford to have a facility of printers that just print transmissions. That doesn't quite make sense to do that yet because of the
cost?
Has a functioning organ successfully been transplanted yet?
Like genetically reproducing organs have, like a larynx has been transplanted, ears, so with pieces in them, like organs that don't have functions, or like huge functions in them yet, have been developed and actually transplanted into people. So like, yeah, ears, and I think they're pretty close to developing bladders as well.
I think DePaul has a pretty printer. CDM.
That CDM building?
Yeah.
It's
So
pretty
you
sweet.
know,
Thanks.
I think you can, I think students, I don't know if they might have access to that, but other equipment.
Okay, yeah, thanks. I didn't know that.